Disposing of garbage is complicated, time-consuming, and requires multiple stops. The distance from a transfer station to landfill is often long, and many landfills are filling up fast. And when the garbage gets to the landfill, the work is complex and costly. With a high financial burden and increasingly limited capacity, waste professionals need to secure their business for the long term. Hughes Energy has the solution. Hughes Energy installs a hyperspeed composting system which will transform 20 tons of garbage per hour into a saleable fiber, a renewable source of energy. The proprietary system uses steam technology to compost in 1 hour all the food, paper, and cardboard into a fiber, which is then sold for profit. Even the recyclables are fully sanitized and ready for sale. With Hughes technology, waste professionals turn a cost into profits. And by diverting all organic waste from landfill, they increase the amount of waste they can accept. Fully modular, scalable, profitable. Hughes Energy helps waste professionals turn costs to profit.
Hello, my name's Tom Wilson, Chief Engineer and Designer of the Wilson System, and we're about to take you a short journey where we'll describe each of the various components that make up the Wilson System. We're now in one of two reception areas on the site here in Limerick. This area is used to receive waste from its transport. It's tipped from the transport onto a flat floor. The waste forms a natural, very shallow angle of repose whereby items can be easily seen and removed. Once the unwanted items are removed, the waste is shoved, it never leaves the floor. A series of elevators carry the waste up to a second series of elevators, and the central control system having made a decision on which autoclave that the waste is going to be transported into. We'll now move on to the next stage of the process. We've just been in the reception area where we've seen waste loaded onto the conveyor system. The waste is delivered to this area, and this area is the autoclave area. There are two autoclaves. Each of the autoclaves rotates, and each autoclave is charged with steam and in a controlled environment. The steam is the element which brings about the necessary conversion of the biomass content of the waste into the fibrous product that you'll see later. Other components within the waste, for instance, aluminium cans, are stripped of lacquer both internally and externally. The cans are flattened due to the dynamic forces within the autoclave. Tin cans are stripped of labels. If there were any beans in the can, the beans are out. The beans are fibrous material, and the beans are also in the fibre. Plastics, because of the temperature in the autoclave, try to revert to their natural spherical shape and shrink duly. Various other materials, rags, etc., remain within the autoclave and are broken up into smaller components. Following completion of the process, steam is discharged from the autoclave under the command of a control system, and the steam that's discharged, in other words the exhaust steam, is condensed and reused within the boiler as boiler feed water. Therefore, we don't waste any of the natural resources that we have here in this plant. Further to that, steam from one autoclave, once its cycle is complete, can be discharged to the next autoclave, saving steam and saving, of course, energy in a different way. We're now in the area where separation takes place of the materials that have been processed within the autoclaving system. Here we have magnets that take out ferrous metals, we have an eddy current separator that takes out the non-ferrous, we have a density separation method that takes refined fibre to storage. What you see here is conventional plant. This plant's used extensively throughout all the waste industry. Here I am now standing in the area where separated aluminium is stored. The value of the aluminium depends on its cleanliness, and here we see clean aluminium stored. In the next bay there are ferrous metals stored. There is a bay for the various types of plastics, and plastics can be segregated into the various different types. And further downstream of here we'll see the major components of or the largest component within the waste stream, the cellulose fibre. Well, here we are now in the area where the fibre is stored. This is the exciting component that we've described all the way up, and at last we're seeing it. This could be, well, in its previous life was a banana, it could have been an apple, it's a newspaper, it's cardboard, it's any natural component, and the natural component being described as biomass. For me, this is a personal achievement. It's a culmination of many, many years of experience within the steam business. Steam in the past has been thought of as an old relic. It's not. This is a new industry. This is the same steam as used in the Industrial Revolution, but is now being used in the waste revolution. Here we have a new industry, steam-driven. This is the end product of the Wilson system. A new industry, a new future, and I hope that you'll be a part of that future.